I'd like to welcome you to the talk on the future of accessing files remotely from Linux. This is a status update on the SMB3.1.1 client, as well as I'll talk a little bit about the SMB3.1.1 server and Samba as well. My name is Steve French. I'm a principal software engineer with Microsoft. I work on the Linux client full-time, but our team works on Azure Storage, XSMB. Legal statement, this doesn't necessarily, these views don't necessarily represent those of Microsoft. Let's see, who am I? I'm the author and maintainer of the Linux cifs client, which is used to access Samba, Windows, various NAS devices, Macs, as well as the cloud, the largest file server in the world, Azure. I'm a member of the Samba team. I actually wrote the initial net utility with Jim McDonough many years ago. I'm the co-author of the SNEA cifs technical reference and former working group chair. And as I said, I'm a principal software engineer working on helping on maintain the Linux client, but working on the Azure storage team within Microsoft. I'm going to talk about recent Linux VFS and file system activity to kind of give you a broader view of what's going on in Linux, and then dive into changes on the new kernel server, as well as changes on the client. And then I'm going to talk a little bit about what client features you can expect in the near future. Then I'll finish up with some discussions of the user space utilities, cifs and the improvements in that area, as well as testing, which has had some really remarkable, excellent progress recently. So let's step back. On Linux, the progress is amazing. A year ago, when I spoke here a year ago, the Linux kernel version was called bobtail squid. And you can see an interesting picture of what a bobtail squid looks like. Now, fast forward to last week, we have the kleptomaniac octopus as the current name. Notice Linux enjoys having unusual names for releases. So we've gone from the 5.3 kernel to the 5.9 kernel. You know, the Linux activity has been amazing, even in this COVID-19 dominated world over the last year. Over the last 7 months, activity has kept up strong. So to give you a feel for what's gone on in the last year, the file system activity is actually up from the previous year. And the file system represents, the file system changes represent almost 7% of the overall kernel changes. And that's flat. That's similar to a typical year, last few. Now the Linux kernel is amazingly huge. Over 20 million lines of source code. I just measured it a couple weeks ago. Now there are many Linux file systems, there are more than 60, but 6 of these file systems and the VFS layer itself drive the vast majority of the activity. They include one local file systems you're well aware of, BTRFS and XFS, and the 2 network file systems, NFS and cifs. cifs has been the most active over the last couple of years. Now file systems represent almost 5% of the kernel source code, but a higher percentage of the changes. They represent almost 1 million lines of code, but they're much more carefully watched than many other areas of the kernel. So they're among the most carefully watched areas of the kernel. Now cifs.ko, the module I work on that provides the SMB3.1.1 support, is the 3rd most active file system with 336 changes. Its activity has been strong. It went up a lot over the last 2.5 to 3 years. Now, the cifs.ko module is 57.2 thousand lines of code, but that doesn't count the user space cifs, which are almost 12,000 lines of code, nor does it count the Samba tool. Samba is over 3 million lines of source code, and we use pieces of Samba for some of the helper functions in user space. And then we rely on other services like WinBind in some cases. Now, let's look at the overall change activity in the Linux file system over the past year, from the 5.3 kernel till now. The largest set of changes overall has been in the VFS layer, the overall file system mapping layer, which includes common functions used by various file systems, as well as the mapping from syscalls into the actual file systems themselves. Over 1,400 lines of code, or sorry, over 1,400 change sets. That is enormous, way, way higher. Some of that's due to work from people like Dave Howells, who are improving the Mount API, doing various cleanup, but it's spread all over the place. Now, traditionally, XFS and BTRFS kind of dueled to see who's the most active file system. And, you know, they're far more active than ext4, but both of them had significantly increased activity. Now, the cifs SMB2, SMB3 client had 336 changes, but as I mentioned earlier, ever since the 4.18 kernel, you'll see the cifs activity has gone way, way up. The NFS client had a similar set of changes, a similar amount of changes last year. Interestingly, ext4, which had relatively much less activity than any of these file systems, their activity did increase. But if you look at the other file systems, you'll notice that very few come close to the activity of those top 5 or 6 that we see there. Now, let's talk about the server a little bit. Many of you are familiar with the NFS kernel server. It had 164 change sets last year. That's a fraction of the changes that went on to, you know, the cifs.ko client or the Samba server. Samba server is as active as all these file systems put together. You know, typically many thousands of change sets a year, and just in the file server component alone, it typically gets over 1,000 change sets a year. So, you know, it's interesting to kind of put this in perspective. Samba's broader in scope by a lot. It's, you know, almost 100 times larger than the NFS server, over 3 million lines of source code. So this gives you a kind of perspective for what's going on in Linux. It's really interesting to see how much activity has been going on. But what people often forget is that it's not just internal things going on inside the file system. They're also adding new syscalls. In the previous talk last year, I mentioned the 15 file system related syscalls that were added. Now, this year, only 3 were added, but that's still kind of incredible. When you think about this, every year we're adding new interfaces to support more applications. We think of POSIX file APIs as kind of a static thing that haven't changed. But in Linux, we don't depend just on POSIX. We keep adding APIs. Last year, IOU ring, Dave Howell's new Mount API, these were big changes. These were very important changes. But this year, we have OpenAT2 in the 5.6 kernel. We have FS Access AT2 in the 5.8 kernel, and Close Range in the 5.9 kernel. These are very important changes, and it's kind of an example of the continued improvements in Linux, some of which are visible to user applications. And as we continue as Linux continues to evolve, it makes our job harder and harder in the file system because we have to be able to support a larger and larger set of API calls. Now, what's driving all this activity? Well, there are many things. Recently, for example, there's been a rewrite of the FS cache layer. Probably 4 or 5 versions of this have been put out on the mailing list. Dave Howells has been driving that. The previous year, we had the new Mount API. And Dave also has proposed some extended ways of querying additional FS information and new notification mechanisms. But we also have changes coming from groups trying to improve the support for containers in Linux. And we've had over the last 10 years or more, many efforts around trying to support faster storage, NVMe, RDMA. These cause interesting problems, right? Where we've had examples. One of the fun bugs I remember was when we had a response returned before the request completed. You know, the strange bugs that are generated in source code by this incredibly fast infrastructure, faster networking with RDMA, and faster storage at the server end with NVMe. This creates great opportunities, but it also creates lots of bugs. And of course, we've also changed the way we think about async I/O with IOU ring. And of course, working in Azure, I see this all the time. We have to deal with the shift to cloud. Sometimes when you're trying to access, you're saving a presentation, you're storing it maybe in Dublin or San Antonio. The latencies can be quite long when you're storing it from very many thousands of miles away. And you're also having to have objects and files coexisting in the same backend storage. You know, the shift to the cloud, though, also means shorter latencies in some cases because we're able to spin up a wide variety of VMs, some with extremely fast speed and very fast networking. So you see orders of magnitude differences in the cloud, which once again causes bugs and causes changes needed in the protocol and in optimizing the client and the server for these unusual workloads that we now see more often. Now, what about the server? We've talked a lot about the Linux client. You know, the Samba server is great. It's huge and full function, but I want to shift gears a little bit and talk about some exciting development. Namjay got a chance last year to talk about his new kernel server, ksmbd, but he's continued to make progress. And I wanted to, since he wasn't able to attend this, I wanted to give a chance to describe some of this new progress on the kernel server. So the module, cifs.d, ksmbd.ko, is over 35,000 lines of code, almost 3,000 change sets. And then it comes with user space tools, ksmbd tools, which are almost 11,000 lines of source code and had almost 1,000 change sets. Now, this ksmbd module, by the way, they call it ksmbd, so it doesn't get confused with the name of the Samba process, the Samba server process is called SMBD. So ksmbd gives you a chance to, you know, obviously see that it's the kernel server. Now, there's a wiki page on this, but here's an example you can see on my system here of starting the ksmbd service and seeing the processes that it launches. Now, this is really good work by Namjay, Sergey, and others. You can see the GitHub tree here. It is still experimental, but the goal is to send it to Linux Next as soon as we can get build verification runs complete. There are also some other changes that have been requested that we'll talk about in a future slide here. Now, it's mirrored onto a tree in GitHub and also in samba.org, and you can see the tree there. Now, the name of the module is ksmbd.ko, but we've called the source directory cifs.d to make it easier to find in the kernel fs directory because we already have an fs-cifs directory for the client and fs-cifs.d for the server. We'll make it a little easier to find in the source directory, but the module itself and the daemon you know, begin with the letter K to distinguish them from the Samba user space code. Now, they've significantly improved the server. Now look at the number of test cases. They pass almost 100 of the XFS tests now. This is good progress. So these are Linux mounts to ksmbd. It's big progress. Now, who uses it? Well, it's included in all the firmware for DDWRT and also OpenWRT. It's included in the base version and also now in the Access Network camera. So as they were distributing these, Namjay and others fixed various compatibility issues with smartphone apps and SMB client and various types of clients, fixed kernel oopses and hang issues and leakages. They found other issues with static checkers. They've applied almost 500 patches since last year's SDC. This has been very good progress in the kernel server. Now, what's in progress? They're adding support for ACLs. So the code implementation is complete, storing NT ACLs into XAdders, and they're now fixing various failures they found from running SMB torture tests against the kernel server. They've also added support for Kerberos, so using the existing Kerberos 5 libraries, it requires an auxiliary user space daemon. Now, some to-dos they're working on, being able to handle open with backup intent, which was needed for some robocopy scenarios, and also being able to support multi-channel. to take advantage of the improved performance you get from being able to use multiple network connections at one time. It's a wonderful feature of the SMB3 protocol. So a lot of progress in bug fixers and also in new features. The ACLs and Kerberos support were two particularly important ones because that was one where some people were hesitant to push forward the kernel server if it had security that was worse than other servers. But adding support for ACLs and Kerberos was a key part of that. So hopefully will help us to make it easier to merge into mainline. The upstream version of ksmbd is now in this GitHub tree that we mentioned here. It's removed the SMB1 code for obvious security reasons. It has much code cleanup. There is various things found with check, patch, and sparse, and it fixed various build errors with the latest kernel. So it'll be the best way to integrate the testing and upstreaming into this in Linux kernel mainline. Okay, let's switch gears a little bit to what are our goals with Linux and SMB3.1.1. Well, we want to make it the fastest, most secure, general purpose way to access file data, whether it's virtualized or in the cloud like Azure or on premises. We need to implement all the reasonable POSIX semantics we can and features. Some of them can be emulated. We don't really want apps to realize they're running on SMB3 mounts. Applications just run on file systems, right? You don't want them to have to think that they're running on a network mount. Right? I was always kind of amused because you see the man page of certain utilities and certain syscalls that mention, well, it works this way locally, but if I'm running on NFS, it does this. Well, we don't want to have to do that, right? We want to make sure that the semantics look reasonably close on the SMB mounts as well as local mounts. Unfortunately, Linux keeps evolving, right? So as Linux continues to evolve, we have to keep adding features quickly to the Linux kernel client and to Samba. You know, we've got some catch up to do still, so we're not at the point where we're, adding support for, the example we talked about earlier with, OpenAT2. What does that mean? Does that mean, do we have to change anything in the Linux kernel client for that? Unfortunately, with rename, we did have some things we're going to need to change, right? To be able to support rename exchange, for example. As fallocate continues to be extended, we will have additional FSCTLs to add. But we need to be able to not wait 8 years, right? Like the IETF sometimes took many, many years to get changes to other protocols. So we want to make sure that we can evolve quickly as Linux keeps evolving. But we want this to be the fastest commodity, sort of general purpose way to access file data. Blocks are great for certain things, but applications often they expect files semantics to work. Now let's look at the new features, the progress in the past year. We added this mode from SID mount option. So this gives us sort of like the NFS style security where in many cases the client's permission evaluation matters the most. There are many cases in NFS where the server doesn't know much about the UIDs, right? You could have clients basically that, the mode bits and the UIDs, the server doesn't really know much about those. This is very different than the kind of Kerberos model that you often see with Active Directory and SMB clients, let's say Windows clients, where when Windows SMB clients or Linux SMB clients are joined to an Active Directory domain, the server is able to resolve these global users to SIDs, to globally unique identifiers, and be able to evaluate these rich ACLs on the server side. Well, the mode from SID option is we're dealing with the primitive POSIX mode bits, and we're trying to store them in a way that's opaque to the server, but allows us to correctly evaluate mode bits on the client. And here's an example you can see on the right-hand side of the page where we have files with every mode bit combination stored. This is similar to what was done in the NFS server for Windows. So the NFS server for Windows had a special SID that was unenforced, but it contained the exact mode bits. So creating files with all 4096 mode bit combination works. Now, what else has been added recently? Well, multichannel was added in the 5.5 kernel. Thank you to Aurelian at SUSE. This is a big performance win. In the 5.8 kernel, in some of my tests, it was 5 times faster, because in the 5.8 kernel, we were able to dispatch large reads and writes. In the 5.5 kernel, all the other I/O types were dispatched in parallel, but not the large reads and writes. So in the 5.8 kernel, you see some much better performance for large file I/O. Multi-channel allows you to take advantage of multiple network adapters at one time and parallelize better. And in Linux, we do a pretty good job of parallelizing writes going out, but reads coming back in aren't parallelized that well, because we end up sort of blocking on the cifs.d thread, reading the stuff off the socket. And even with offloading it to network adapters, we have bottlenecks there, especially with encrypted connections. Now we do have an E-size mount option that can help parallelize a little bit, but multi-channel does a much better job. So this has been a great performance win, and we see some really promising data, not just to Windows, but also to Azure. It's really kind of fun. I've enjoyed, seeing in many cases 2, 3, 4 times faster I/O, and it's a wonderful feature of the SMB protocol. So here's a network trace of multi-channel. You can see the different colors representing the different adapters that it's going over, and this is a nice way to see how these requests are being parallelized across multiple network adapters, allowing us to achieve better performance. Now, what else has been added? If you look at this, the XFS developers back a couple of years ago, 2.5 years ago at the File System Summit, talked to us about dynamic tracing. And a year later at the File System Summit, the developers of the BPF subsystem, these dynamic tracing infrastructure improvements, gave talks to the file system and memory management developers about how important dynamic tracing is and what can be done. So we've continued to add dynamic trace points, and here's a list of the 82. We continue to add more and more every year, and as we debug customer problems, we add more. Dynamic tracing is so much better than the typical tracing that's been going to dmessage, and I think that it's really helped a lot in helping us as developers debug customer problems better, and also develop code faster. And dynamic tracing has been fantastic for cifs, and I recommend strongly you take a look at Brendan Gregg's books, and there's also, I think, a presentation here at the on this conference about using BPF. But in cifs, we have a large number of dynamic trace points, and they've been very helpful. Now, one of the things that was so much fun last year was the ability to add support for GCM. And this was added in the 5.3 kernel. It can more than double the write performance and improve read performance by 80%. It works very well with Windows, and then there were fairly recent changes a year or so ago to Samba. So now mounts to Samba can also benefit a lot from this. So GCM is quite fast. And as we go forward, we're also going to see support for GCM signing coming. And I don't know exactly the time frame for that in Windows, but it's going to be a big help. So I'm finding that very exciting. But I think everybody benefits from this if you're encrypting data, that is. So for example, when you mount to Azure, you're encrypting by default. And typically, these secure mounts that are encrypted had been an obstacle for Linux, because it could take as much as sometimes 8 milliseconds to encrypt a very, very large frame. And with GCM, the performance can go up 5 times faster for encrypting these frames. So it's kind of a really neat feature that we added last year. Paolo at SUSE added the ability to boot diskless systems via cifs.ko. That was added in the 5.5 kernel. And here's an example of it here. And it's actually kind of interesting because in some of these early examples, he booted over SMB1 because of the SMB1 Unix extensions, but he was able to get it with SMB3 as well. there's no IPv6 support yet, and it does require IP config to set up the network stack prior to mounting. There's a nice write-up on this, and I think that there are use cases where diskless systems make a lot of sense in SMB, allowing more control over it. And in some environments, diskless systems are going to make more sense. I think as we improve our support for the POSIX extensions, booting diskless over SMB3.1.1 is going to make even more sense. But this is a really fascinating feature, and the changes went into the 5.5 kernel. Okay, so let's summarize some of these changes fairly quickly. So that have gone in over the past year, because there's been a lot of exciting progress. In the 5.3 kernel, we cut the number of round trips from 3 to 2 in open. That improved performance about 10%. We added the GCM crypto, which can more than double the write performance. Copy file range, which allows for faster server-side copy, now supports being able to copy from 2 shares on the same server, so you can do a cross-share copy offload, not just within the same share. SMB Direct is no longer experimental. Longlead did some wonderful work there, and I think you're all aware that RDMA is extremely fast, and SMB support over RDMA is a very, very powerful feature. We also added the ability to send the network name, context, and negotiate protocols, which will help load balancers in some cases. And we can now query symlinks that are stored as reparse points. In the 5.4 kernel, we can now boot, but there were some networking dependencies that were required that went into 5.5. The mode from SID mount parm was added. We talked about earlier slide. For workloads where you have large encrypted reads that you need to do, the mount parm e-size allows you to offload encrypted, which helps performance of large I/O in some cases by parallelizing decryption. We had some customers requesting the ability to disable leases, so that's possible now with the no lease mount parm. We also added some much improved user space tools to allow better debugging and certain system admin tasks. And as part of that, we added support for a pass-through ACL to allow user space tools to call various set info levels directly from user space. Thanks to Ronnie at Red Hat for work on that. We also, from some customer requests, added the ability to force caching. So basically cache equals read only and cache equals single client. And also signing using the current signing algorithms is slower than encryption actually. And there are some cases where by disabling the signing checks on the client, you can get better performance, and in some workloads that's okay. Obviously, signing has significant value in preventing corruption and also man-in-the-middle attacks. So this is not recommended in all cases. But if you need to disable signing validation on the client, it can improve performance. We added a mount parm for some customer requests for that. So we also have the ability to display the maximum number of requests in flight, and which another feature that's been incredibly helpful is the ability to now dump the decryption keys. So if you want to, you've mounted with SMB to a server that has an encrypted share, you can now debug that by running SMB info and the name of a file, and it'll dump the encryption keys for you, which you can then plug into Wireshark. And thanks to Aureliana Tusa for some of that. In the 5.5 kernel, we added support for whole file locks. We emulate whole file locks, the BSD style locks, and we added multi-channel support. We also added a performance optimization that helps metadata queries. So we cache metadata for 1 second, but we now query the metadata on close, which allows us to cache it for 1 more second beyond close. And that's improved performance. And we also did a reader performance optimization when you have reparse points. Now in the 5.6 kernel, we improved the mode from SID mount option. We also added support for fallocate mode 0 for non-sparse files. We had some things coming from Boris that allowed setting the owner info, DOS attributes, and creation time from user space, which helps some backup and restore tools. We also added Ronnie at Red Hat did a performance optimization that added compounding support for reader, which cuts the number of round trips from 9 to 7 for a typical ls command. And that significantly can improve performance when you're doing a number of readers. And we also added reader improvements for mode from SID and cifs.ko, so we don't end up messing up the mode bits and having reader overwrite the mode bits we just got back from stat. We also added a new octal for change notify. This is helpful for user space tools that may want to wait on directory change notifications. Currently in Linux, there is a change notify and iNotify API, but it doesn't work for network file systems. It only works for local file systems. There's a VFS change, there's a patch set that's been proposed for that to fix that. But in the interim, we have an ioctal that can be used to call change notify to allow user space tools to wait on directory changes. In 5.7, we had a big performance improvement for signed connections when multiple requests at the same time, with much better parallelism. We made a number of RDMA improvements and added support for swap over SMB3. In the 5.7 kernel, we also came close to finishing the Unix extensions by adding support for the POSIX reader using the SMB3.1.1 POSIX extensions. In the 5.8 kernel, Aurelian made a big performance improvement for large I/O with multichannel, allowing multichannel to parallelize large reads and writes, which can make it 4 or 5 times faster in some cases. We also added support for something called IDs from SID, which allows an alternate way of handling chown. So mapping POSIX UIDs, GIDs, owner information to a special SID. We also added this last key part of the POSIX SMB3.1.1 POSIX extensions in the 5.8 kernel, adding support for POSIX query info. So what improvements should you expect in the near future? So one of the things that you should expect is much stronger encryption. So at the last storage developer conference, they talked about AES-GCM-256, something that helps with the most demanding, most secure workloads. We currently use AES-GCM-128 or CCM-128. GCM-128 is a little faster. So I've begun work on adding support for AES-GCM-256 as an option to allow us to handle those workloads that require even stronger encryption. Currently, I don't see a reason to do CCM-256 because GCM-256 is likely to be faster. So this is going to be helpful for that subset of workloads that demands the best encryption. Now, in addition, one of the problems that we have had is that encryption is faster than signing because signing relies on a slower algorithm. So there's a new negotiate context that allows other signing choices, and that works in progress. And what this will allow us to do is choose GCM signing, which would allow, hopefully, signing to be faster than encryption. I've begun work on that, and I can see negotiating with the server, but I still not complete yet. But that's something I've been working on, and hopefully we'll continue testing at the co-located SMB test event this week. Now, we also have a problem that was noted recently as we were investigating some performance issues. When a server, like Samba in some cases, Samba doesn't support directory releases. Well, in some of the changes we made to allow better caching of the root directory, we end up now doing an extra set of round trips. So we've added compounding support, which would normally reduce round trips, but we end up doing an extra set of round trips for query of the root dir when a server doesn't support directory releases. So that performance fix is being worked on right now. Shyam's been working on a number of cifs.ko improvements, things to, for example, handle cases like where the mode bits are 0707, where a better example might be 007 or 077, where the owner has less permissions than the group or everyone. There are a number of cases where we have to add deny aces to be able to properly match the mode bits for some of the cases, like the example I gave, 077. So he's been working on those improvements to cifs.ko, as well as some better Kerberos integration things. So when we mount with Kerberos, we can upcall a little bit better and find the default tickets a little bit better, and also deal with generating the tickets in cases where we don't have it. Make it a little bit easier to do multi-user mounts. So another thing that that's been in progress, we need to improve caching. So NFS often caches file data across close. So there are certain benchmarks that actually don't send any network data because the file is cached the whole time. They set up the temporary file, close it, it stays in the cache, so there's no network IO for those. SMB has a similar feature called handle leases, and we can do the same thing. And doing that will improve workloads where you do open, write, close, open, read, close. In addition, we need to extend the use of directory leases, which are incredibly helpful for improving metadata. Today, we only do it for the root directory. We need to be able to extend directory leases to subdirectories as well. We'd been worried a little bit about starving the server for sources, but I think that's less of an issue now. And so another thing that we've been working on is extending directory leases to improve our metadata performance, ability to cache subdirectories, the metadata associated with subdirectories. And we need to continue to optimize network traffic. SMB has a wonderful feature called compounding that lets you reduce the round trips. And Ronnie did some wonderful patches roughly a year and a half ago. And we've continued to do them to improve the performance of reader, to improve the performance of stat. And there are many, many IO patterns where we can send multiple requests to the server as one, reducing the round trips and improving performance. The problem is we have to just keep looking case by case by case and find these. Another thing we need to work on is, although the multi-channel performance is getting better, it's still somewhat experimental, because if a multi-channel disconnects, we need to improve how we handle reconnect in multi-channel. So when a session drops in multi-channel, we need to do a few more patches to fix that. So we have some new features that are very exciting that have gone into recent Windows. I was downloaded the recent Windows Insider build, and it was kind of fun because you can see the GCM encryption here. Here it's trying to negotiate. You can see AES-256 GCM. And here's an example from the Linux client from yesterday, where we enabled require GCM-256. You can see the Echo 1 module cifs parameters require GCM-256, which causes us to only send GCM-256. And this allows you to require that when the best encryption is required. And then we try to do a mount. Now the mount's going to fail because the code isn't quite finished yet. But you can see in this Wireshark trace that we've actually successfully negotiated GCM-256. And where we fail is the tree connect, where we have a problem in how we're calculating, I think how we're using the session, how we're using the key to encrypt that first frame. So this is something we'll be working on at the test event over the next few weeks, and hopefully we'll have ready for the 5.10 kernel to be able to get the best encryption. And what about Quick? Now, Quick isn't just about avoiding the port 445 problems. There's lots of other advantages of Quick as well. But the lack of a kernel network driver for Quick has been a key issue. It's been discussed, and there's an MS Quick GitHub project that could be used as a starting point. And the discussions are continuing here, and hopefully we'll be able to talk more about that. Now, Wireshark now has support for SMB3.1.1 over Quick. Here you can see Windows negotiating Quick. And so what about other security improvements? We need better SE Linux integration. We need support for more security scenarios. We need to improve the support for multi-user Kerberos mounts, something Cheyenne's been working on, the stronger encryption, and the port 445 problem. We also need to be able to support dummy mounts so we can handle KRB5 credentials when they're not available. But one thing that's been interesting is to look at the different security models. We have a case where we're enforcing permissions on the client, like mode from SID, IDs from SID, in cases where we're doing multi-user and enforcing it on the server with cifs.ko. And then we have cases where we're using the default. These three models have to be supported well, and there's some unusual combinations of all of these that we have to continue to extend and document. cifs utils has improved a lot. SMB info has been rewritten in Python. There's some great examples. Kenneth D'Souza did a nice job of pass-through ioctl to get quota information. So it's kind of a fun tool. Here's a sample example of using it to get quota information. Now, what about typical user scenarios? One of the common questions we get asked is what mount options should we use? It's very common to use MF symlinks to be able to have client evaluated symlinks that are safer than having the symlink stored on the server. It's also common when you're to mount with no perm, especially if you have ACL set up properly on the server. It's also very common to use a default dir mode, file mode, UID, and GID. It's faster than mounting with cifs ACL where you're retrieving those out of the ACL on every stat call. But it's sometimes recommended that you want to use the cifs ACL if you want to have server enforced permissions, or IDs from SID and mode from SID if you're enforcing them on the client. It's very common to mount with AC timeout with a larger value than 1 second if you can relax metadata consistency requirements. Also, it's very common to mount with SFU if you have the need to store special files. And also for servers like Azure that do highly reliable backends, you may not need to send sync calls to the server. So you can sometimes rely on mounting with no strict sync. No strict sync will allow a little faster performance when your server backend is reliable enough that you don't have to be sending the SMB flush command to tell the server to write it to disk. Now testing is significantly improved. So take a look at our build bot, take a look at the XFS testing page. It's very easy to set up to exclude slow tests, failing tests. We've now up to 180 groups of tests that run over SMB3. That's more than run over NFS. And we keep adding more every release. We added more than 50 XFS tests since last year. This has really helped a lot with reducing regressions, and we're going to continue to add more and more XFS tests as we work through one by one. There's a lot of XFS tests, many of them only appropriate for a local file system, but this has been extremely exciting progress. And thanks to the build bot, we've had the best releases ever for SMB3. Fewer regressions, much higher reliability, much higher quality. So the future looks very bright for Linux and SMB3.1.1, and I'm very excited about the progress that we've made. Now, during the co-located test event, we'll have a chance to do some, this test event that's going on the same week. We'll have a chance to make even more progress, but I look forward to hearing more about the kind of requirements and suggestions you guys have and experiences you have using the Linux client. The Linux cifs mailing list and Samba Technical are excellent resources to use for getting more information. And here's some additional resources you can use for exploring SMB3. Anyway, I want to thank you for your time, and I look forward to hearing more feedback and questions. And hopefully, we can continue to extend the workloads that the Linux client can work on, and also hopefully can get this Linux kernel server in so we have lots of choices both on the client and on the server for accessing files remotely. Thank you very much for your time.